So my dear participants, so today we are having a resource person from AI chapter Coimbatore, Mr. Navneet Malingan. He is a very young and dynamic person. He has been associated with our institution for the past 3 years in our various academic endeavors. So I feel very proud to introduce the very young guy, Navneet Malinga, for this technical session 1, 2, 3 of day 2. He is the founder of Nunnari Labs Private Limited, Coimbatore, and he is also a lead as a course instructor and content creator for Femtech Poland, and he is also act as a lead and coordinator speaker for TensorFlow user group Coimbatore. He is also acted as a head and dean and mentor for Coimbatore AI chapter, and he is also act as a resource person in Nivu Academy to mentoring the students for online and offline education. He is also act as a lead and IoT developer at Wavy, Texas, USA. He is a software consultant for Yanni Technologies, Coimbatore. So I feel so happy in introducing such a resource person for this technical session 1, 2, 3 of day 2. Now I request Navneet Malinga to take this session. Thank you.
Good morning, sir. Thank you for the warm welcome. And good morning, everyone. Hope you can hear my voice clearly, I think. Is it audible?
Yes, sir. Yes.
Yeah, okay, fine. So give me a minute. I'll just share the screen. 1 second. Okay, hope you can see my screen, I think.
Yes, sir.
Yes, okay, sir. Yeah. So again, thank you, Saktivil sir, and thank you, Ramakrishna Mission Institutes for giving this opportunity. And good morning and welcome, everyone. I think today's 3 session will be handled by myself, and the topic will be on LoRaWAN. Before that, a little bit of me. Currently, I'm working as an AI and IoT developer, a researcher, and educator at Nunnari Labs and New Academy, and also acting as faculty for adjunct faculty on AI and ML for a few colleges in and around Coimbatore, and handling 2 AI communities in Coimbatore. So I'm an hardcore software engineer. I used to build a lot of things, but I'm still interested in education. So I'm involved in a lot of education activities these days, and one among is these FTPs and corporate trainings and workshops that I frequently do. And today's session is on LoRaWAN. I think before getting into the session, I need to ask a question like, how many of you have already worked on LoRaWAN, or else at least heard of LoRaWAN? Can I get some answers in the chat box? Hello. So about LoRaWAN, have anyone used or else have anyone heard of? Okay, new to LoRaWAN. Others heard but no idea. Heard little. Okay, fine, great. So LoRa and LoRaWAN. So it's a very broad area. IoT itself is a broad area, and again, LoRaWAN has a lot of components. It's not as simple as other IoT protocol. Okay, it's a pretty large, and it has a lot of components in it. So my goal for today is for 3 sessions I will be having like 4.5 hours. I'm sure that I can make you understand what is LoRaWAN, and I can deliver, or else I can make you a good LoRaWAN developer at the end of the day. Okay, so that's my objective for the day. Okay, So we will go every step by step. For the first session we will cover every theory, okay, what theory part and why LoRaWAN, where to use and how to use, and how you can build application using LoRaWAN. That will be on the first session. And second session we will directly jump into the code, okay. So we will install a lot of components in our system. I'll be live installing all those systems in my local laptop, and set up the LoRaWAN environment, hardware and software both, okay. And third, in the afternoon session, we will try to build an end-to-end application in LoRaWAN. Okay, so an end-to-end IoT application in LoRaWAN. So that's the three things that we are going to do today. Okay, fine. So LoRaWAN, it's an IoT protocol. Okay, so why IoT? So why do we need Internet of Things? Okay, so we have Internet of computers. We have Internet of mobile phones. One second, this is a problem with my slide. Uh, yeah, fine. Okay. So why IoT? We are trying to put everything onto the internet. Okay, so that's an objective. That's the primary goal. But what are the applications? Let's see some application, and let's see why we want to do that. Okay, so first thing, we have connected and autonomous vehicles. We have sports and entertainment things, and we have wearables. We have smart cities. We have smart homes. Okay, and we have smart factories, automation, agriculture, and healthcare, and IoT security. So we have a lot of things, but the primary objective is connecting things to internet. Like it might be anything. It might be an animal, like a pet dog. It might be a machine, okay, some factory machine. It might be a vehicle. It might be an house. It might be a door. It might be a smart glass. So everything that we are trying to put into the internet, okay. So I used to tell this example, like the very first IoT machine that we were unknowingly using is called like kind of an ATM machine. Okay, so ATM machine is a money vending machine, right? But it is connected to the internet. It can communicate to the server, and yet it can do some physical thing, right? So it can vend us money, or else we can drop in money, and it will add it to our account. Okay, so it's been for a long time, but now we are trying to connect everything, almost everything. There are connected wallet, there are connected water bottles, okay, so there are connected pet dogs. Why do you want to connect this? Okay, so the first question comes, why IoT? Okay, so if you see about the Tamil Nadu's uh, cab system, okay, so the popular one was, when I was in kid, the popular one was fast track. Okay, so the fast track is the cab that was quite popular in and around Tamil Nadu. So wherever we want to go, we just wanted to call them. They have a toll free number. We have to call them, and you have to book a cab. Okay, someone will be sitting in the office, and he will be communicate with the driver. Okay, and he will tell us where to pick and when to go. Like we have to book one day prayer. Okay, so things were happening like that. But now, Ola and Uber. Okay, so if you talk about fast track, it's like pretty hard, and that it's very time consuming, and like it's very pricey as well, because he can have only one or two ride per day, and it is very costly as well, and an adult only can use that service, right? But now just think of Ola is always connected. Okay, so you can track your driver, you can know the location, and you can track the customer as well. Okay, so where the customer is, and you can easily pick him up. Okay, and a lot of data analytics is happening in the happening big in the scene. Everything is seamless. Okay, and it is less time consuming. Okay, and also it's less pricey, and even a 10-year-old kid, with the help of a smartphone, he can book a cab and commute from one place to another place. Okay, so see how efficient things are. Like that's the power of connectivity. Okay, so once everything is connected, okay, to some system, we can efficiently monitor it. Okay, so once we can monitor it, we can optimize it to make it better. Okay, so that's the idea, right? So we can if like any system, let's take any system, an institution, or else a medical system, or else a government. So if we able to track it properly and know what is happening, and where there's fault, we can optimize it and make it efficient. Okay, so that way, like IoT enables us to track and monitor things efficiently, and also actuate back. Okay, so we can give the command back to the system to do some actions. Okay, to stop or to start or whatever it is. Okay, so in a very broad abstract perspective, so IoT system can be used to effectively monitor and maintain a system. It might be any system, and also we can both monitor and control. Okay, so either we can fetch data from some field or some system and we can analyze those data, or else we can give some command back and control them. Okay, so let's take if it is an agricultural field, so we can monitor all those soil minerals and water content and all those stuffs we can, and plant growth, everything we can monitor it. And on the other side, if you want to actuate it, we can turn on some motor, we can give commands to put some pesticides or something like we can enable them. Okay, so that's IoT. But so far what we are doing is like IoT. So I've been working on IoT since 2013. So back then, the term itself not that quite popular. So we called as like whether wireless sensor network or else machine to machine communication. Okay, see we call it like that, like machine to M, M2P, P2, like that. Okay, so uh, so far what we are trying to do is like initially when the IoT was quite popular, we were trying to adapt the existing technology. Okay, what are the existing connectivity technology? You can take Ethernet, you can take Wi-Fi, you can take Bluetooth. Okay, you can take Zigbee, or else the mobile radio like 2G or 3G. 4G is just recent, back then was 2G and 3G. So we try to use all those radio technology or communication technology to build an IoT system. Okay, so that's what we have been done in the past, right? But these LoRaWAN or NB IoT, narrowband IoT, is the part of LTE 4G thing. Okay, and if you see Sigfox and weightless, okay, so and Thread, so all these protocols are IoT only protocol. Okay, so from ground up they have been developed only for IoT. So if you see other 3G or 4G, so they can be used for voice communication and data communication and IoT. You can see Ethernet. Ethernet is used to connect systems to a router and make a LAN or WAN, whatever it is. But it can be used for IoT. But those things are developed for a different purpose, but used in the IoT ecosystem. But if you come to LoRaWAN, it's dedicated and from ground up, from scratch developed for IoT applications. So why we need a new protocol? Okay, so your question comes right. So already we have all sort of systems, but why do we need a new protocol? So if you see the characteristic of an IoT system, okay, so it's a general characteristics. Okay, so it has to be a low power device. Okay, so low power device in the sense it is able to run it should be a battery operated device, and it should be withstand for more than few years, like at least like 5 years. So that's an optimal value. Okay, so you can't keep on replacing the battery or recharging it daily. Okay, so that's the first thing, low power. And the second thing is it should have a long range. So long range in the sense, for long range you can take 3G or 4G network, because it's a mobile network. It can give you long range, but at the same time, if you see the power consumption of those systems, if you turn on mobile data of a 4G network, within few hours your battery will get drained. Okay, so even though you have like 3000 milliampere or 4000 milliampere battery, it will be get drained within few hours, like maybe 5 to 8 hours. Okay, so but that is not suitable. So we need low power, we need long range. Okay, and the third thing is it has to be reliable. Okay, so reliable in the sense, so there are time critical applications. Okay, so let's say a factory. Okay, so let's say there's a factory system. If you doesn't turn off the system in a particular time, the machine will break down, or else some healthcare devices. Okay, so if it is a real time, so there are certain like in IoT there are a lot of different pattern. There are real time systems, there are non real time systems. Okay, but if it is a real time system, things has to be and if it's a time critical thing, it has to be like very reliable, right? And fourth thing is secured, so it has to be end to end encrypted. Okay, so whatever the data flows in and out within to the system, it has to be very secured. So because again, let's take medical data. If someone is able to sniff your medical data, they can manipulate it, and again they can change it and do whatever it want. Okay, and similarly a lot of systems are there, it has to be very secure. And fifth thing is, if you see, these IoT devices are run by tiny microcontrollers, right? So those tiny microcontrollers are very memory limited. Okay, so memory limited and compute limited. So both those are not huge processors with huge amount of RAM and hard disk. There are tiny microcontrollers like Atmel or ARM or PIC microcontrollers. So there are very memory constraint and compute constraint, and even they run in just few megahertz. Okay, so 80 megahertz, 100 megahertz, not like our powerful system which can run in gigahertz. The frequency itself like it's few megahertz. Okay, and the sensor you have is MEMS and low power sensors like micro electromechanical sensor or low power sensor. So if you take an IoT system, so these are all the ideal conditions it should have. Okay, and if you see the protocol side, okay, so we have Bluetooth and we have Wi-Fi. Okay, so Bluetooth is normal. We can use normal Bluetooth or Bluetooth low energy. Now we have Bluetooth 5 and 6, which can operate in low energy mode, but Bluetooth is one general protocol. Okay, communication protocol. And next we have Wi-Fi, which is very common for internet and creating a LAN, wireless LAN. Okay, and next we have 6LoWPAN. Okay, so it is IPv6 low power personal area network. Okay, so it is it's a mesh protocol. Okay, so it's used for a lot of IoT systems. Okay, and next we have NFC, near field communication. Next we have Thread, and Thread is kind of similar to Zigbee or 6LoWPAN, and again it's a mesh protocol. And next we have LoRa and LPWAN. Okay, so LoRa, long range low power wide area network. Okay, and we have RFID just for authentication and other kind of things, and we have Ethernet to build a network, and next we have cellular. Okay, so when it comes to internet, the core component is the processing unit. Okay, the processing unit and the sensing unit and the communication unit. So when it comes to IoT, the main core part is the protocol unit, the communication protocol unit. So we have all these protocols, right? But where does LoRaWAN stand? Okay, so why do we need LoRaWAN even though we have these many protocols? You see, an ideal LoRaWAN system should have a good battery life, and yet it should give a good range. Okay, if you see this sector, okay, Wi-Fi, Wi-Fi will give very short range. Okay, so all the Wi-Fi network and will be considered the range is around 100 meters. Okay, so if it is in within house, it is restricted to like few 30 or 50 meters. But if it is an open area, it can cover up to 100 meters. Okay, but you can see the battery life is very low because Wi-Fi is a high bandwidth protocol. You can transfer Gbps of data in an like in and out of the network. Okay, so so it is very power consuming. Okay, and on the other side, if you see within the same range, within the same 50 to 100 meter range, we have BLE, Bluetooth low energy, and we have Z wave. Okay, they are very good at battery life, but they can give a short range only. Okay, and high bandwidth. You can use Bluetooth to stream audio. Okay, your wireless Bluetooth headsets or else your Bluetooth speakers. Okay, so they can stream high bandwidth data, but yet and again there are short range, few meters. Okay, but they give good battery life. Okay, but even though they give good battery life, they are short range devices. Okay, and on the other side we have long range devices called like cellular. You can use GSM modules. Okay, 2G, 3G, 4G. Okay, you can use GSM modules. They can give long range because they have mobile towers deployed and they can cover up to few kilometers, like 5 kilometers, 5 to 10 kilometers. But you can see again battery life is a problem. So battery life on the lower side. Okay, so battery will drain quickly. So there's a new area. Okay, LPWAN, low power wide area network. Okay, so all these things come under local area network, like LAN. Okay, LAN or PAN, personal area network or local area network. Okay, and these things comes under WAN, but low power WAN, low power wide area network. Okay, that's where the LoRaWAN, narrowband IoT, Sigfox, LTE-CAT-M. So LTE-CAT-M and NB-IoT are the part of 4G standard. Okay, it's the protocol is defined by the 3GPP, 3G third generation partnership protocol, like the organization which define all the GSM, 2G, 3G and protocols. And this Sigfox is from a private entity, and LoRaWAN, it's a kind of proprietary, and yet the LoRaWAN is a open source community driven protocol. Okay, So we have all these things in the low power wide area network. So they can cover up to a huge range. Okay, so LoRaWAN, they tell in city condition they can give up to 1 to 2 kilometers range, but we have tested in Coimbatore, and we have got about 12-kilometer range. Okay, with LoRaWAN, and the battery is also quite decent. Okay, so we will see how it is able to do that, right? So again, so that's about the cost and the advantages. Okay, so first thing, wired. If you see, we have Modbus and other protocols. Okay, it's legacy installed. Okay, but you need cables. Okay, so wherever you wanted to have the network, you need cables. And the second thing is short range. Short range, we have Wi-Fi, Bluetooth, Z-Wave, Thread, and Zigbee, but they can be easily installed. But coverage and construction, so coverages, they cannot give coverage area up to an huge net area, and also the power consumption is quite high. And if you see the LoRa, Sigfox, and NB-IoT, so you can see 16% of the devices, and it is growing. Okay, you can see very good coverage and battery, but the downside is it gives very low data rate. Okay, so data rate is the problem here, because when it comes to LoRaWAN, when it comes to Wi-Fi and Bluetooth and other wired systems, they can stream high bandwidth data. They can stream audio, video, and the transfer speed is always between few Mbps. Okay, sometimes you can reach up to Gbps as well, but the ideal is few Mbps it can transmit. Okay, but LPWAN or IoT only protocol, they can be, they have very low data rate. Okay, so the maximum is 50 kbps, I think. 50 kb is B for byte. Okay, 50 kilobytes, and the data is always sent in bits. Okay, so we will see the exact numbers, because different configuration will give us different data rate. It is able to send only sensor data. Okay, so just think of, if you want to turn on a device or turn off a device, you just wanted to send a single bit, either 1 or 0, along with some address and like location around the data. Okay, so that's all you need to control a device. And similarly, if you want to getting data from some devices, it might be some temperature data or some other data. It has to be just numbers. Okay, just few 8-bit or 16-bit numbers that you would be transferring through the LoRaWAN. So it can give very good coverage and also very good battery life, but the downside is data rate, because it's an IoT only protocol. And on the other side, we have cellular. It is very good coverage and installation, but power consumption is very high. And again, satellite, it can cover and it can be available everywhere, but again, the cost is too high. Okay, yeah. So these are all the protocols, different set of protocols for different sectors and different applications, and their advantages and disadvantages. Okay, so we will focus on this part, LoRaWAN. So if you see the competition for LoRaWAN, so we have Sigfox. Okay, Sigfox is Sigfox is a proprietary technology. It's been maintained by the company Sigfox itself, and LoRa and LoRaWAN is maintained by LoRa Alliance. Okay, so LoRa, in LoRaWAN, we have two things. One is the LoRa radio protocol, okay, the physical layer, and we have the LoRaWAN, the network and MAC level protocol, okay, which is maintained by the LoRa Alliance. So now the LoRa is a part of Semtech. Okay, so the developer been recruited, like they have been made a part of the Semtech company, and they have made it as a proprietary technology. So only Semtech, SEMTEC, Semtech is the company. They can create the LoRaWAN chips, the radio protocol chips, and LoRa chips, and the LoRaWAN can sit on top of it and do certain things. Okay, so we will see all the component bit by bit, and you can see data rate is 100 bps, bits per second, and here you can see 300 to 55 bits per second, 5500 bits per second. So if it is bits, if you want to convert into bytes, B, capital B, then we can divide by 8. So let's divide by 10, which is 550 kbps. Okay, so it's very limited. Okay, and also in certain region we cannot reach up to high data rate. It's very restricted. And you can see payload is 12 bytes. It's 50 to 255 bytes, because all the headers and other stuffs will be covered. Okay, and it's proprietary technology, it's open technology. Okay, and radio, if you see, radio is open, but the radio is proprietary. So if you see the difference here, here the network standard is proprietary. Okay, but the radio technology is open in the sense it uses normal FSK or other normal modulation scheme. But here in the LoRa, the network standard is open source. Okay, but the radio is proprietary. The radio is LoRa. So LoRa uses a particular modulation technique called chip spread spectrum technique, so that it is able to encode the data within up chip and down chip, and that is able to easily encode data within the radio signal. So we will come to that. Okay, so that's the difference between Sigfox and LoRa, right? And again, same thing, just to cover, like we have LAN, short range, okay, low power wide area network, okay, and we have cellular network, and you can see it's 40%, 45%, and the market cap, like, okay, you can see. And LPWAN, you can see all these stuffs, okay, but they have written as high data rate, but LPWAN are not for high data rate, they are low data rate but emerging technology, right? So if you come to a low LPWAN, low power wide area network, okay, so what are all the things it has to have? Okay, so we have network architecture, okay, and backend architecture, communication range, it has to be good, battery lifetime or low power, robustness to interference, okay, network capacity, it has to handle maximum number of nodes, okay, and if you take network security, it has to have good network security, and one-way and two-way communication, and variety of applications served. Okay, so all these things, we will see every topic one by one. Okay, so first LoRa. So first let's see what is LoRa. LoRa stands for long range radio communication. Okay, and it is a physical layer protocol. Okay, so just like FSK or QPSK, or else some other BPSK, like phase modulation or frequency modulation. So all these things are physical layer, the radio level protocol. Okay, they are used to encode and modulate signals. Okay, so LoRaWAN is a physical layer wireless modulation technique, okay, for long range communication link. Okay, so LoRa uses a technique called chip spread spectrum modulation. Okay, and because it's slightly different with the frequency shift keying, we can see it encodes the data using up chirp and down chirp. Okay, so if you see the modulation, it will be like this. Okay, so these are like up chirp and down chirp. Okay, so we have different spreading factors. Okay, based on different spreading factors, it is able to encode the data within those up chirp and down chirp. Okay, but you don't have to further dig into LoRa, because LoRa is a standard modulation scheme. It is already embedded within a protocol. Okay, so we can directly right away use it. You don't have to configure anything within this LoRa system. Okay, we can directly use it. But in order to know, this is a unique way of encoding data into the signal. Okay, so there will be a carrier signal, there will be a message signal, you will be encoding the message signal into the carrier signal, right? So the encoding happens with this particular part. Okay, the chip spectrum part. Okay, so it's a tongue roller kind of thing. Okay, and if you see the LoRa modulation, it is not that as abstract as other things. If you say Wi-Fi, so Wi-Fi is made very abstract, and you will be having access only to the very top layer, the application layer. Okay, so the application layer in the sense, it might be an HTTP or TCP/IP, or else something related to that. Okay, so it's very abstract. You cannot touch down the lower layers. Okay, you can only have access to the higher layers. Okay, but in LoRaWAN, you have the access to the entire stack, like right from the radio layer to the application layer. You can modify or configure any layer. Okay, so you know the 7 OS layers, right? Okay, and before that, I just wanted to add some in. So this IoT is a equal combination of electronics, okay, and also computer science. Okay, you need to know equal amount of cloud and radio protocols and the networking protocols and electronics. Okay, so only then you would be able to build an end-to-end system. Okay, so I'm an electronics engineer by degree, and I slowly picked up all these clouds and communication and software things. Okay, so you have that 7 layers. Okay, so in LoRaWAN, you can configure and modify any layer, and you can tune it based upon the need. Okay, so if you see about LoRaWAN, we have these modulation schemes. Okay, so we have certain data rates. Okay, so here it is, everything is configured using data rate. Okay, so data rate, you can see the top here, the orange line, so it ranges from 0 to 7. Okay, so here it is 0 to 7. Okay, so that's a data rate. So you can give 0, 1, 2, 3, 4, 5, 6, 7. So you can configure it. So let's say you are configuring it as 0. Okay, so the data rate is 0. Then it is a low data rate. Okay, because see, here in LoRaWAN, you can build a system based upon the requirement. Okay, so if you have a short range, okay, if you need a short range but high bandwidth, okay, short range, high bandwidth. If you want to transmit more data, you can go for short range. Okay, but if you need a long range, okay, long range, then you will have low bandwidth. Okay, low bandwidth, and low bandwidth is a low data rate, like low payload capacity. So it's a trade-off, and the trade-off can be configured by ourselves. Okay, if you want need few kilometers, then we can send only few bits and bytes. But if you want to send data within few hundred kilometers, let's say 500 kilometers or within 1 kilometer, then you can have a slightly more data rate to transmit more input in and out data. Okay, and you can see if you configure data rate as 0, it can give very big range. So this black color is range, so it keeps on increasing. Okay, it keeps on increasing. And if you see the spreading factor is 12. Okay, so if you give here, the spreading factor is range from 7 to 12. Okay, so let's put it like okay, 7 to 12. If you give 12, then let's say you have a bandwidth like this. Okay, so this is fixed bandwidth. So bandwidth, you can see here, it is it can have 125 or 125. But if you give 12, it can give long range and more spreading, because even a small amount of data is spread. Sorry, there is small problem with the internet. I think hope it is fine right now. Okay,
Sir,
and you can
sir, excuse
hello.
me, sir.
Yeah, hello.
Sir, few minutes before, some voice breakage is there, sir.
Okay, sir. I think the internet is slightly unstable now. It is fine, I think. Okay.
Okay,
Yeah,
sir.
I'll repeat the stuff, sir. No problem. Okay.
Okay, sir.
So yeah, so just keep in mind of these things. Okay, so just keep these things in your mind, because these things should be like very too much, but we will do hands-on while in the afternoon session by configuring all these parameters by ourselves. Then you will get a clarity. But anyway, just think of the data rate is the number what you set to your system. It might be 0 or minimum 0 or maximum 7. So if you give 0, you can get maximum range. Okay, so this maximum range on the paper, they tell it is about 10 to 15 kilometers. Okay, but in city condition, we can get easily get between 1 to 2 kilometers. Okay, but LoRaWAN, they have experimented up to 400 kilometers. Okay, so 400 kilometers, it's just a test. What they have done is they have put a LoRaWAN node into a hill, into a balloon. Okay, and they have flown it, so it have traveled to a huge height, and it has received the data in various gateways. Okay, from a different place, and it has covered up to 400 kilometers, but that is not for practical applications. So yeah, so if you give data rate 0, low data rate, you can send only low data. Okay, small amount of data, but it can give huge range, and the spreading factor is 12, and the bandwidth is 125. And we can see the bit rate bpps is 292. Okay, 292 bits per second. Okay, so that's the ideal condition. Okay, ideal data rate for this. And you can see the time on air and consumption. Okay, so time on air in the sense, so if you spread this amount of data into the entire radio channel. Okay, and so it will take more time to reach at the receiver end. Okay, so the time on air and consumption is more. But and again, you can see the receiver sensitivity is minus 136. So LoRaWAN, LoRa is able to pick up the signal with up to minus 150. Okay, so here it is just minus 136. It can pick up to 150, so that even your radio signal is damaged or degraded, it is resilient enough so that it can be decoded efficiently on the other end. Okay, so these are the parameters we have. Like on the other end, if you give it 7, okay, it kind of uses the it is give short range. Okay, but spreading factor is 7, so the data is not spread to the entire bandwidth, it's spread little. Okay, and you can use bandwidth 250 or 125. You can use both the both the bandwidth. Okay, and if you set to 250, you can see you can use up to 10K. Okay, 10K bps, okay, bits per second. Okay, and again receiver sensitivity would be -120, and you can see time on air is very less because it's a short range, and you have used a modulation scheme, a spreading factor of 7, so it is able to uh, transmit the data much faster. Okay, data will be sent quicker. Okay, so these are all the configuration parameter for LoRaWAN, right? So as I said, in other technology, let's take Bluetooth or Ethernet or GSM, all these things will be fixed. So it will have a standard bandwidth, it will have a standard modulation scheme, it will have a standard encoding and decoding mechanism that is not configurable. Okay, so you have access to the very higher abstract layer, but here you can configure all these parameters, right, based upon the application. Okay, so as I said, LoRa is a proprietary technology. It's a modulation scheme. Okay, it uses CSS, chip spread spectrum. So it has all these configuration parameters for the radio channel. Okay, and you can see only Semtex, the company, they manufacture these microcontrollers. Okay, you can see them LoRa transceiver here. So it has the radio layer, the protocol stack, UART, all sort of interfaces. Okay, and you also have RM2483, which is a microchip chip, a LoRaWAN chip, which has the Semtech radio module along with a microcontroller inside. Okay, so we will use the Semtech rack module for today. Okay, so to build our application, right? So next, let's come to LoRaWAN. Okay, so now we have seen LoRa. Keep in mind, LoRa is just a radio protocol. Okay, and you can configure the bandwidth, data rate, range, and spreading factor, and all sort of things to the LoRaWAN radio protocol. And LoRa is a proprietary technology. So keep that in mind alone. Okay, and the next thing is LoRaWAN. So what is LoRaWAN? WAN is a wide area network. It's a network level protocol. Okay, so LoRa stands for long range, WAN stands for wide area network. Okay, so what LoRa can do? LoRa is a physical layer. It enables long range communication link, highly dependent on environment. Okay, within cities and buildings, it can give up to 2.5 kilometer approximately, and countryside and in other rural region, it can cover up to 45 kilometer. Okay, and data rate is 0.3 to 50 kbps. Frequency in Europe is 868 megahertz, and in India it's about 867. Okay, so in other few countries, in India we have ISM band 2.405 to 2.485, and also in 5 gigahertz. Okay, but we also have a small bandwidth of small spectrum of ISM band in the 400 megahertz place, and also in 867 place. Okay, but in European countries, 860 to 870 is a ISM band. Okay, and duty cycle is 1%. Duty cycle is like the amount of airtime it is occupying. Okay, and on the other side, we have LoRaWAN. LoRaWAN defines the communication protocol and system architecture. Okay, so it's kind of acts as a backend, right? So remember, we have 7 layer, right? Okay, so we have 7 layer. We have physical layer, we have MAC layer. Okay, and we have network layer, and on the top we have application layer. Okay, so it's a standard OSA protocol. We have 7 layers. So LoRaWAN comes under this side. Okay, this is just LoRa, and LoRaWAN will be take care of this network and MAC layer protocol. Okay, so LoRaWAN, and as I said, uh, LoRaWAN, the radio protocol is proprietary, but the LoRaWAN is open source. Okay, so it's maintained by a alliance called LoRa Alliance, and companies like Cisco, IBM, Semtech, and the Things Network, TTN, Swisscom, and PFH, all these are the part of this LoRa Alliance, right? So you can see, so here RF layer in Europe we have 868, 433, in US is 915, and Asia 430, in India and other countries we have different things. But you can see the physical layer and the RF layer kind of handled by the LoRa, and on the application layer and the MAC layer, so here it is maintained by the LoRaWAN. Okay, so let's come here. So on top of LoRa modulation, LoRaWAN, what it does is it kind of classifies the devices into 3 classes. Okay, so it's kind of in the network level protocol, it kind of segregates into 3 different classes of devices. Okay, so one is class A, another is class B, and class C. So why do you want to create a class A, class B, and class C? In the sense, so based upon the different need. Okay, need in the sense, see, let's come to class A. Okay, class A is mostly only for sensing. Okay, sensing or else uplink. Okay, so class A is mostly used for only uplink, so it cannot do downlink. So as I said, IoT is used for two things. Either you can transmit data from the sensor to the cloud, or else you can control the device from the cloud. So either you can send data to the cloud, or else you can control it from the cloud. Okay, but this class A devices, they can do downlink, but mostly used for uplink only. Okay, so that they are optimized, so the class A level of protocol and the timing schedule, so we will see in detail about class A. I just wanted to give a glimpse about what it is. Okay, so it has been designed, and all the scheduling, all the uplink and downlink, so all the time, so everything is been designed based upon keeping in mind it can do only uplink. Okay, on the other side we have class B. Okay, so class B again, it's used for mostly uplink only. Okay, but it can also do scheduled downlink. Okay, scheduled downlink. Okay, so so again, class B is mostly used for transmitting data to the cloud, but it can have time scheduled slots. Okay, so whenever you wanted a downlink, you can send the data in that particular time. Okay, and third we have class C. Okay, class C is always uplink. Okay, and always downlink, so you can do both uplink and downlink anytime. Okay, so that's the three categories: class A, class B, and class C. We will come to that in detail. Okay, we will build application using all these three different types. Okay, and on the other side we have Mac options. Okay, on the other side we have LoRa Mac and applications, so we can configure whole lot of things on top of it. Okay, so LoRaWAN is a network level and Mac level protocol. In the Mac level, it kind of segregates the devices into three classes: class A, class B, and class C, and each has different configurations. Okay, and also we have the network level protocol. Okay, network level protocol used to orchestrate, or else used to manage the joining of network, and all sort of things, right? Okay, and if you see this particular LoRaWAN architecture, okay, it's a end-to-end LoRaWAN architecture. Okay, so here you have end nodes. Okay, and end nodes, it might be a pet tracking or smoke alarm or water meter or trash container, vending machine, gas monitoring. These are all the applications. Okay, all these are end devices. So these end devices can be class A or class B or class C. Just think of all the devices are class A. Okay, so these all the class A devices will be connected to a LoRaWAN gateway. So we call it as LoRaWAN gateway, or else a data concentrator. Okay, so gateway is nothing but, just think of it like a cellular tower. Okay, so you have end devices, the mobile phones, but you have a cellular tower, right? So the cellular tower is a single point, and it can connect up to like 50 to 100 devices at a time. Okay, so a single cell phone tower can only accommodate that many. Okay, so it's basically, it's a star. Okay, so we have a gateway, all the devices are connected to it. So from the gateway to the devices, it's a star network, right? So all the devices have point to point, one point connection to the gateway to the end node. So behind the gateway, there sits the network server. Okay, so this network server is also a pure code. Okay, so it's defined by the LoRaWAN and by the alliance. Okay, it's just a pure software. uh, this network server will keep in track of all the devices. Okay, all the IP addresses. Okay, it's not IP address, we call it as a device address here. Okay, just think of it like, just to an analogy I'm telling, it keeps track of what devices is a part of the network, all the authentication. Okay, all the data filtering. Okay, data deduplication, and this network service is responsible for a few things. Okay, we will come to that one by one. Okay, and on the other side we have application server. So this application server is used to further abstract things. Okay, so on the back end we can create applications. Okay, within applications we can add all these devices, and we can generate keys, and we can use those keys to connect these devices to the gateway. Okay, so these are all the component, and the LoRaWAN kind of decides the application server, network server. Okay, and the gateway concentrator, and the software will be run on this part as well, and also on the end device as class A, class B, and class C. Okay, so the LoRaWAN takes care of all these four components, right? And you can also see the end-to-end encryption and all. Okay, we'll come to that later. Right? So let's see the classes in detail. So class A, class B, and class C in detail. First, let's see about the devices. Then let's come to the LoRaWAN stuff. Okay. So here you have battery life on the y-axis and downlink network communication latency. You don't think of uplink, it's downlink, okay, on this area. If you see class A, battery powered sensors. Okay, so first thing is battery powered sensor, and you can see most energy efficient, must be supported by all devices, and you can see downlink available only after sensor TX. Okay, so why the downlink is, see, this class A is always in sleep mode. Okay, always in sleep mode. Okay, so you cannot actuate it from outside because it is, the radio is off. So in a device you will have like this. Okay, so let's come to an microcontroller device. So here you have microcontroller. Okay, and here you have sensors. Okay, and here you have radio. Okay, so radio has two things, like humans, it should be having the ears. Okay, it should be have the mouth. Okay, so either it can transmit a radio electromagnetic signal and transmit, or else it should continuously listen for electromagnetic signal for incoming. So if the radio is always on, the current will be consuming. Okay, so that's the key thing. And also if the device is always on, and again there will be some power will be drained for the microcontroller operation as well. Okay, in the hardware level, we have these microcontrollers, sensing unit, radio, and the battery. Okay, so all these things are connected with the battery. So this is the fourth thing which we have in a microcontroller. Okay, so if the radio is always on, the battery will be drained, so that this class A device is kind of always in a radio sleep mode. So the radio will be sleeping most of the time. So whenever it wanted to send an uplink, okay, so let's say there is a machine which is continuously running, or there is a temperature monitoring. Okay, so whenever there is temperature crosses greater than 40, okay, so temperature crosses greater than 40, then we want to send a uplink. So in that case alone, this radio will come online, will send the data to the server. Okay, send the server, in the sense it will transmit a LoRa packet. That's all it has to do. So it will be received by a gateway. Okay, a gateway will be there. Within the range of this gateway, this device will be there. It will send a uplink LoRaWAN. So only after the successful reception of this uplink data, two two downlink slots will be open. Okay, so I'll be like, to put in simple, I'll be sending an uplink and I'll be listening for two slots. Okay, two downlink slots. Okay, let's stay like 10 seconds, or else I will send a data called 1, and I will receive data called 1 and 0. Okay, I can send one data and receive two data, and once I receive two data, I will go to sleep again. Okay, I will not continuously listening for the data. So that's how class A devices are created. And you can see there are battery powered. Okay, so that's how the radio is always in the sleep mode, so that it can give a long battery life, like maybe few years. Okay, so that's the thing. But the disadvantage is the downlink can be only happen on only when there is a uplink is happening. Okay, but you can ask how, because if you want to send a data to the class A devices, how you can do, in the sense. So as I said, right, so we have network server. Okay, so we have gateway, so we have LoRa end devices, we call it as ED. Okay, and we have gateway, and we have network server, and we have application server. Okay, so this application server is kind of a front end, you think of it like this. Okay, front end. So this network server is the network manager. Okay, network manager in the sense it takes care of who is in the network, and see all these devices, it knows, this network server knows, okay, this node is within my network. Okay, it knows all those things. And gateway, it is used to send and receive data from the end devices. Okay, and if you want to send a downlink to the LoRaWAN, what you have to do is, from the interface, okay, you wanted to send the data. Okay, let's say turn off motor. Okay, turn off motor, and I'm giving data is equal to 0. So this 0 is the data will be sent to the application server, and it will be sent to the network server, and it will be scheduled here. So it will be in the pipeline for the downlink readily. Okay, but let's say this devices only comes online uh, twice per day. Okay, so this class A devices comes online only twice per day, maybe 12 a.m. and 12 p.m. So when in 12 a.m. this device sends the uplink to the gateway, and this gateway device will be sent to the network server, and from the network server to the application server, and to the mobile app or whatever it is. So then it knows, okay, this particular device has sent an uplink, and already there is a downlink message scheduled for this particular device, then I will send this downlink device. I will send to the gateway and I will transmit it, and this class A device will receive. Okay, so that is how you can do the up downlink in the class A devices. Okay, you can schedule it. Okay, you cannot send all the time, and that is class A. Okay, and next we have class B, which is battery powered actuators but energy efficient with latency controlled downlink. Okay, and slotted communication synchronized with a beacon. So what they're telling is, in class B, again it works same as class A. Okay, it can do only uplink, and it will get two downlink slots after one successful uplink, but also it has scheduled downlink in the sense, you can schedule like by 1 o'clock or 2 o'clock. For every 1 hour, I will be sending a downlink. So what this class B device will do is, for every 1 hour or a certain time, okay, certain interval, it will come online and listen the radio for 1 or few minutes, and it will go to sleep. Okay, so it is scheduled downlink. So it can do always uplink, but scheduled downlink. Okay, that is class B. And if you see class C, it is main powered actuator. Main powered in the sense, there is a constant backup power for it always. Okay, so an EB connection, or listen a huge power supply, continuous power supply. You can say device which can afford to listen continuously. So it will be, the radio will be always on in the class C, and there is no latency for downlink. So but here and here it is latency, because here only you can do downlink only after successful uplink. Here you have to wait for the timing to come for the device to come online, so that only you can do the downlink. But this is always uplink and always downlink. But the downside is, the radio and the controller will be always on, power will be drained. Okay, so these LoRaWAN or the protocol, power and range are the top priority here. Okay, so unlike if you use Wi-Fi, there is no need to think this much. Okay, so everything is already fixed, but you have to use only the mains power. You cannot have a battery operated device with Wi-Fi. You can do, but it will not give up to few years. Okay, you can use ESP modules or Raspberry Pis, but you have to connect a power bank. Okay, few 10,000 milliampere power bank you have to connect it, and again it will get drained within few days or in 1 or 2 weeks. Okay, but all these LoRaWAN devices can operate in button cell. You know the button cell, right? The cell what you get in your watch is a tiny button cell battery. So that button cell battery, which has very low memory power, very low current. Okay, and it can run with those button cell for few years. Okay, then think of how optimized the protocol is, and how optimized the class A, class B, and class C things. Okay, so yeah, so that's, we have three categories. So that's all about device. Okay, class A, two short receiver windows after uplink. Class B, slotted downlink. Okay, and class C, receive continuously. So that's the difference, right? And if you see the channel bandwidth and stuffs and all, okay, frequency band. Okay, so in the Europe it's 867 to 869. Okay, and in North megahertz, in the North America it's 902 to 925 megahertz. So there is also another thing, Wi-Fi, kind of Wi-Fi, Bluetooth, and all sort of things runs in the band of 2.405 to 2.485, which is the ISM band. Okay, so yeah, so that is 2.405 to 2.485 gigahertz. Okay, and the entire bandwidth is 80 megahertz. Okay, so this minus, okay, if you do minus, it will give 0.080 gigahertz. So that is, you add three zeros, then 80 megahertz. So within this 80 megahertz, it is further subdivided into 16 channels. Okay, 16 channels. These 16 channels is being used by the Bluetooth and Wi-Fi for all sort of communication. So that is how within these 16 channels only our household router, mobile hotspot, and other stuff work. And on the other side, LoRaWAN uses this sub gigahertz spectrum. Okay, sub gigahertz in the sense within 1 gigahertz. Okay, so in Europe it's 867 to 869 megahertz. In America it's 900. In China it's 470 to 510. In Korea it's like this. In India, if you see, it is 865 to 867 megahertz. Okay, so that's the spectrum availability in India. And if you see the Europe and North America, all these ISM band, so this is an ISM band. Okay, industry, scientific and medicine bands, and free to use. Okay, all those devices we can, this unlicensed band we can use it for any purpose. Okay, but in other countries all these bandwidth also been regulated. You can see there have been 10 channels, and channel bandwidth, it is very restricted to this channel bandwidth, and the uplink and downlink power is also regulated. You cannot transmit in high power. Okay, and spreading factor is 7 to 12. Here it is 7 to 10, but in India it's definition by technical community. But India has released its own this radio specifications. I will show you the document, but that is not that hard ruled. Okay, so it's very flexible. You can configure it with any spreading factor, with any data rate, with any power. Okay, fine. So that's about the spreading, that's about the spectrum availability in India and other countries, right? And if you see the difference between LoRaWAN, NB-IoT and other protocols, you can see LoRaWAN uses chip spread spectrum. Okay, and narrowband IoT uses GFSK, BPSK, and the CAT uses OFDMA, orthogonal frequency division multiple access. And again, all the LTE standard kind of uses OFDMA only. But you can see bandwidth is 500 to 125 kilohertz, and all these things are kind of within the same range, right? This is a bandwidth, and data rate is 50 kbps. Okay, 290 bits per second to 50 kilobits per second. So that's the bandwidth it gives. But you can see messages per day, it is unlimited. Okay, so you can send any number of messages per day, but in other countries again it is regulated. Okay, and narrowband IoT, you can send only 140 messages per day. So all these protocols have been developed because, see, let's say if for people who are not from communication background, I'm just telling you an example. Okay, telling you and putting an easy analogy. So let's say you are talking. Okay, so if you're talking, if you want to tell a word, again, let's take it takes 2 seconds. Okay, and let's say this, let's say I'm telling yes. Okay, yes is a word which will take 1 second to pronounce. Okay, I'm telling yes, and I can tell this yes with very loudly. Okay, I can tell loudly yes, or else subtly yes. Okay, I can tell like that. But this, if some people is standing nearby, they can easily pick up my voice, they can easily hear. But let's say the same person is standing some 100 meters away, then I have to shout. And you know the sound wave, it will take some time to travel because it travels through air molecule. It will take some time to travel. So that the time taken for me to tell the word is, and for the time taken for the reception, okay, for the person who is standing 100 meter away to receive the my word, it will take 2 to 3 seconds. Okay, so let's say we are sending this data. So s is a small word. Okay, so s is a small word. It has a certain like the data rate will be, let's say it's a few bytes. Okay, s is an English word. Let's take it is uh, like 24 bits per second. Okay, or else some 100 bits per second. Okay, and again, the range we have to decide whether it is far or short. So basically completely it takes few seconds. Let's take 3 seconds. But if the sentence is long, it may take 5 seconds or 10 seconds, like that. Okay, so let's take for 1 minute. So you can tell 20 s. So you can send 20 data for 1 minute. And for 60 minutes you can tell like 60 into 20 into 24. Okay, so let's round it off to 20 hours. So 2 into 2 4 4 into 6 is 24. So 24,000. So per day only 24,000 messages can be sent by one person. So this is for totally. But let's take there are 100 devices or 1,000 devices in your area, then each can send only 24 messages per day. So that is how the time is also divided, because in communication protocol, all the modulation scheme, even though it is frequency modulated or else some other modulated, the time is an important component here. Okay, so if the data is more, if the modulation scheme is very complex, it takes more time to reach at the other end. In the same time, if some other data comes, interference will happen. Okay, so there have been a lot of mechanism to avoid all this, like CSMA, carrier sense multiple access. But this LoRaWAN doesn't use CSMA and all. It will just transmit the data. Okay, but if multiple devices transmit the data at same time, let's say I'm telling yes and you are telling no, and 4 or 5 people are talking at the same time, everything will be interfered and no one will be able to understand what who is telling what. Okay, so that's the case here. So similarly, yeah, so this one, if 1,000 nodes are connected to the gateway, then only 24 messages can be sent per day. So while designing an IoT system, all these things would be taken into consideration, right? Okay, fine. And you can see interference immunity is very high. Why I'm telling all these things in the sense, teaching IoT in a very abstract manner is a different thing. You can just take a Raspberry Pi and you can write some Python code and turn on LED and turn off LED. But that's not actually what IoT mean, right? So IoT is like very radio level and chip level configuration to build an efficient IoT system, right? Yeah, so you can see the battery life, it's about 105 months, right? So maybe 100 months is few years, right? 5 to 10, 8 years. And power efficiency is very high. Interference immunity is also very high. But if you see narrowband IoT is very low and other things are very medium or low, it's very interference immunity because of the modulation scheme, right? And coexistence, yes, it can coexist with other protocol because GSM uses the same band. GSM is around 900 megahertz only. Okay, the 2G communication. The 3G and 4G uses 1.5 gigahertz and 1.8 gigahertz. I think I'm not sure about the numbers, but again, it's more than 1 gigahertz. And security is very high, and mobility and localization. So here you can see limited mobility and no localization in the sense, limited mobility in the sense, and NB IoT devices can be only deployed. It can have minimal locality. Let's say there's a mobile tower here. Okay, this device can be roam in and around only this mobile tower. Okay, so if you move out of this mobile tower, your connection will be lost. But in basic mobile phone call, you can travel. Like, remember, you would have talked to some friend or phone while traveling. So there what will happen is every time you switch, you enter a different region, handoff will happen, mobile handoff. Okay, so a sudden cut will happen and immediately another tower will pick up, and your voice and the incoming and outgoing will be taken care by the another mobile tower. And on the other side, so that way handoff can happen. So here you can see there is no localization, but handoff can happen in LoRaWAN because as long as it has it is in the range of the gateway coverage, it can send data to any gateway, right? Fine, so we have all these properties. And if you see the advantages and disadvantages, so let's take an application scenario. Okay, let's say you have 2,000 apartments and 80 buildings slash stays and sensor cost. Okay, so let's say you wanted to deploy an IoT system for building monitoring. Okay, you can see the price is about design and preparation, some kind of 4,000, repeaters 32,000, concentrators 20,000, and installation 24,000, and some is about 80k euros. Okay, and business and logistics, you have all sort of things if you go for Modbus or some wired system. But on the other side, if you use a LoRaWAN system, okay, average 5 sensor per apartment, temperature, humidity, and warm water consumption, okay, fire detection, and all sort of things. You can see design and preparation 1,600, gateway 6,000, okay, and installation 880, and you can see 8,000. So the cost is 10 times reduced, and also there is no maintenance, everything is wireless. Okay, everything is radio. Okay, you can easily deploy and build your network. So that's the cost application. Also LoRaWAN is like that, very good for deployment purpose and all, right? So what LoRa provides, what LoRaWAN provides: four things. Long range, okay, greater than cellular coverage. As I said, it can cover more than 10 to 20 kilometers. Deep indoor coverage as well. If you are deploying in within buildings and apartments, it can give coverage over there. Star topology, so all the nodes are one hop away from the gateway. They can directly send data to the gateway, and it's not that this node will always send the data to this gateway. This node can send data to any gateway. So there might be a gateway here, there might be a gateway nearby, there might be a gateway on another side in a different region. So when this gateway goes down, okay, let's say this gateway covers this region, and this gateway covers this region, okay, and this gateway also covers this region. So it will transmit data to all the three gateway. Okay, but all these three gateway will have a common backend. The common backend is the network server. Okay, so even though the data is being received by multiple gateway, this network server will try to deduplicate the data. Deduplicate the data in the sense that one same data will be sent by the node. So this packet will have some identification. We will come to the packet format. Okay, if it is sending some data, this packet will have some identification. So it will be sent to the all the gateway within the range. All the gateway data will be sent to the network server. This network server deduplicates. Okay, there is a single identification. So three gateways sending the same data. It network server takes care of the thing, right? Yeah. So next we have maximum lifetime, low power optimized, 10 to 20-year lifetime they are telling. Okay, so and again multi-usage, high capacity, multi-tenant and public network, because see a single gateway can handle a practical use case can handle up to few hundred nodes. Okay, and again as I said, it has time constraint. If 1,000 nodes are there, and only 24 times each node can talk. Okay, but if there are only 100 nodes, then 240 times 40 uplink or downlink every node can do. Okay, so it's high capacity, multi-tenant and public network. So it's a star of star. So an n number of devices can be connected to a single gateway, and very low cost, minimal infrastructure. Okay, we'll come to the gateway part, and low cost at the node end, and open source software. So these are all the four things that LoRa provides, right? Now let's come to the LoRaWAN part, right? Yeah, we have 24 minutes more. We'll try to cover all the theory part, and in the next session, we'll directly jump into the code, right? So LoRaWAN, as you said, LoRaWAN defines the communication protocol and the system architecture for the network, while LoRa is a physical layer, enables the long range communication. That I have repeated more times. You should be having those idea, right? And what LoRaWAN does is, LoRaWAN, the protocol and network architecture, it can do battery lifetime of a node. Okay, because uh, LoRaWAN is what defines a device as class A, class B, and class C. Remember, we have seen three classes, right? So LoRaWAN is decides class A, class B, and class C. And network capacity. So based upon the LoRaWAN only, how many node can join a single network can be decided. Quality of service, because you can have uh, a confirmed uplink or unconfirmed uplink. So if you send a confirmed uplink, for every uplink you will get an acknowledgement message. So I have sent the data safely to the gateway. You will gateway to the network server. You will get a acknowledgement. But if you send an unconfirmed packet, you will not get the acknowledgement. Okay, so there you have a lot of quality of service configuration. And security, LoRaWAN uses 3-level security. We will come to that, and variety of application will be served. Okay, so all these things LoRaWAN will take care, right? So LoRaWAN consists of it's not LoRa, it's LoRaWAN. Okay, so LoRaWAN consists LoRa network. Okay, LoRa network consists of gateways, network servers, okay, and end devices. So end devices are the devices deployed in the actual places, and gateway is the point of contact for these end devices. Okay, and the network server behind the sits behind the gateway. Okay, yeah, and you can see the topology is star topology, right? And everything uses ISM band, and it's a single op. So if you take other protocol like Zigbee, it is a mesh protocol. Okay, so here you have a gateway, you will have nodes like this. So if this node wants to reach here, it has to take hop. Okay, go like this. But here it is a single point. So there is a gateway, and all the nodes are in single op. And so there is an the gateways and network servers can connect to IP backhaul connections. I'll draw it. Okay, and communication between end device and the gateway are carried out in different channels and different data rate. Okay, because each can use different channels, and each can have different data rate, because some might be transmitting more data, some might be sending less data, and depending upon the distance also, the data rate trade-off changes. Long distance, less data rate; short distance, more data rate. Okay, but in the both the places we will get very good power. Okay, very good energy efficient power consumption. And LoRa supports adaptive data rate as well. We will come to that. Okay, fine. So yeah, so we will come to this part. Okay, we will come to this fact. Before that, we will uh, okay, we will okay. I have this thing, right. So I'll try to draw things and make things clear. Okay, so let's take, you have an end device. Okay, by the time I have told a lot of things, let's summarize things. You have an end device. Okay, is an end device. Okay, so this end device will have a microcontroller. Okay, will have a sensor. Will have a radio. Okay, and will have a battery, right? So this is an end device. So this radio can be LoRa. Okay, and this radio, on top of radio, you will have a other stack protocols. Okay, other communication stack protocol. So this is a physical layer. Okay, physical layer, and here you comes the network layer and MAC layer. Let's say we have configured it as class A. Okay, so it's a class A devices. Okay, class A device, right? So here we have a network layer, MAC layer. So all these things are software. Like, don't think of like all these things comes as a chip. This network layer and MAC layer is a pure software. If you are coding using Arduino or using Raspberry Pi or Python, all these things are some code. So protocol is nothing but a set of rules, right? So rules in the sense it's a kind of a language. So this LoRa device has to obey all these rules in order to efficiently communicate to the other devices. Okay, so that's we have end device. Okay, so from the end device, let's say we have class A, there will be gateway. Next is gateway. Gateway, I will draw a single gateway here. Okay, so this gateway will have two things. One is this gateway will have packet forwarder. Okay, packet forwarder. Okay, and also gateway bridge. Okay, packet forwarder and gateway bridge. Okay, so it's a gateway. So remember, we have a lot of gateways. So here it is gateway, here it is gateway, and here it is gateway. Okay, so we have a lot of gateways. So let's say they have range and they have range. Okay, this arrow mark is it's reachable, but this is not reachable. Let's say some other device over here, end device, and they are reachable. Okay, so here we have 4 gateways. And the next important thing is these gateways, or the backend for this gateway is Ethernet or 4G. Okay, just think of like it can have a backend. Okay, the backend or hall. Okay, backhaul is Ethernet. Okay, the TCP IP, or it can have 4G modem. 4G modem. Okay, so 4G modem is what provides this gateway the internet. Okay, and next, these Ethernet and 4G, they enables internet, and through the internet, I will draw the dotted line. Okay, through the internet, they are connected to the network server. Okay, network server. Okay, so this network server, and next we have application server, app server, application server. So all these things can sit on the cloud. On the cloud, let's take AWS. In Amazon Web Server, there's a Linux machine. Okay, Linux machine. So in the Linux machine, this network server and application server are installed. Okay, so it might be an so this network server or application server, again, they are pure code. Okay, they are written in Golang. Okay, they are written in Golang, or there is also Python or Node.js implementation, but mostly they're written in that. Okay, so all these gateway will be connected to the network server. Okay, all these gateway will be connected to the network server through internet. Okay, so I'm drawing a dotted line, gateway to connect to the internet through the dotted line. Okay, fine. Now how things happen is, so and from the app server, you will have another connection. Okay, and there you have your monitoring device. Let's say mobile app. So there you can have some meters and monitoring stuffs. Okay, 123, some numbers. You can get the data over here. So how things goes is, right, from the sensor. Okay, sensor is, let's say you are monitoring temperature. Okay, so monitoring temperature, the sensor senses the external environment. Okay, this temperature, again, it's a thermistor, it's a resistor. Okay, so based upon the temperature, the resistance in the sensor will change, and based on that, you will calculate the temperature. It's a pure voltage difference. So based on the voltage difference, you calculate the temperature. Let's say 30 centigrade. Okay, 30 Celsius. So it's been computed with the microcontroller, and this microcontroller knows, okay, it is 30 degrees centigrade. This microcontroller will on the microcontroller only this network and application level MAC level protocol sits, and they kind of creates the packet format. Okay, they put the packet format, they put all the header and footer, all sort of stuffs, and they will place the payload. Okay, 30 degrees centigrade. Okay, so all the data will be in hex in the binary. Okay, so this packet, data packet, is transmitted through the radio. Okay, so through the radio it is transmitted. Okay, so the electromagnetic signal is transmitted. So then it is a LoRa packet. Okay, so from here it is a LoRa packet or LoRa radio, LoRa packet or LoRa radio. So here it is where it uses the LoRa protocol. Okay, LoRa wireless protocol it uses. So this LoRa packet can be received by multiple gateway within the range. Okay, so there, let's say we have these two gateway, or within the range of, like, this node is within the range of these two gateway. Okay, so because each gateway can cover different area. Okay, so wherever, so this during uplink it will just transmit. Okay, I'll just shout, whoever there is available, you just listen to me. So that's the idea. So there is a gateway here, this gateway here, this gateway receive these LoRa packet. Okay, so as I said, right, this gateway will have another component also called packet forwarder, and on the top it has data concentrator. Data concentrator. So this data concentrator is a 8-channel data concentrator, 8-channel receiver and transceiver. Okay, so 8-channel transceiver, I will write TRX. Okay, transceiver, transceiver, transmitter and receiver. Okay, so this data concentrator receives the LoRa packet. Okay, and demodulates it. Okay, demodulates it, and there is a component called packet forwarder. So this packet forwarder is what like kind of converts the LoRa packet into the UDP packet. Okay, what it converts LoRa packet into UDP packet, normal TCP/IP or UDP. TCP/IP will get acknowledgement, but UDP don't get acknowledgement. You would convert into an UDP packet. So this UDP packet, it's a IP. Okay, it's an HTTP protocol, like it's a TCP/IP protocol, right? So once the data concentrator receives the LoRa packet, it packet forwarder kind of converts the LoRa packet to a UDP packet, and this UDP packet is sent to the network server through the gateway bridge. So gateway bridge is the component, sits on the gateway. Okay, it sends the UDP packet to the network server. And similarly, this gateway also has access to the data, and it also does the same thing. It receives the data, converts the data, and converts into UDP packet and sends it to the network server. So this network server will keep track of all the devices. Okay, what all the devices is within our network, because you have to register the device to the network. Okay, so let's say you wanted to use a Vodafone network. What you have to do? You have to buy the SIM card and you have to register your mobile number network, right? So similarly, these nodes will be registered under this network server. So we will see the all those configuration how to do that. So this network server will receive these UDP packets, and it will deduplicate it. Okay, and find whether, okay, the original and evaluates whether someone from our network only sending the data or someone outside of the network. If some outside packet enter into the network server, it will just neglect it, it will just drop it. Okay, so other data is received, and this network server is further it does all the initial checking and sends the data to the app server. So app server, it's kind of very abstract thing. It has all those top level applications and the device added to it, and from the app server you will have a external application, a monitoring system, a dashboard, or else an mobile app, which you can see the data. Okay, so you can see from the node to gateway it is radio protocol. Okay, LoRa radio. From the gateway to the network server, it is a UDP packet, but it can be a Ethernet connection or it can be a 4G connection. Okay, from the network server to the app server, because if both are in the same server, it is just a IP connection. This application runs on a port, this application runs on a different port, so it sends here. From here to here you will be using MQTT. Okay, so MQTT is another application level protocol like HTTP or REST. It is another application level protocol. Using MQTT, you can fetch the data from the application server and view it in your mobile app. So that's the end-to-end LoRaWAN system, how it works. Okay, fine. And now let's get back to the this diagram. Okay, you can see. So here you have a node. Okay, So this is the original architecture of chips track. Okay, we will come to that. So it is, we have node. Okay, so this node will be sending the data to the gateway. So some gateway will have the packet forwarder gateway bridge both within the gateway itself. Okay, both within the gateway itself. But some will have only packet forwarder. Okay, so in that case, this gateway bridge can sit in the server itself. Okay, so either you have packet forwarder and gateway bridge within with the gateway, and you have the LoRa server and app server in the server, in the cloud server. That is one set of kind of setup. Or else you can have the packet forwarder alone in the gateway side, and you can see from here to here it is a UDP packet. Through the UDP packet it goes to the gateway bridge. From the gateway bridge it uses MQTT to connect to the LoRa server. This LoRa server is the LoRa network server. Okay, it connects like that. From the LoRa server to LoRa app server, it is gRPC. So Google's remote procedure call, that stands for gRPC. Okay, so these two things always stays together. Okay, but this packet forward and gateway bridge, either they can stay together or they can be in a separate they can be in a separate places. Okay, so and again from the app server you can use MQTT to build your application. So this application can be an mobile app or else an monitoring system. Okay, mobile or web app, an application to monitor all the data. So that is how the architecture is designed. Okay, fine. And now let's come back to the uh, key components of LoRaWAN. Okay, the key components of LoRaWAN in the sense, see when you okay, so before that we'll try to skip these stuff because in the next session we'll be creating all these configuration on our own. We'll see that in that time. Okay, yeah, we will see about LoRaWAN limitations. Okay, so LoRaWAN S list, where to use LoRaWAN when you need long range, few kilometers, then you can go for LoRaWAN. And power which can last months on battery or even years, in that case you can go for LoRaWAN. Low cost, a single node will cost less than 2000 or 3000. When you go for bulk manufacturing, you can also reduce up to 500 rupees or 1000 rupees. And low bandwidth. Okay, like 400 bytes per hour. And coverage, so if you have gateways installed, you will get coverage for a huge for a longer area and region. And secure, it's an end-to-end encrypted. We will come to that. Okay, so this is where the places where you want to use LoRaWAN. But no list is real-time data, because there is, if there is some time critical data, either you can go for class C, but if you are using class A or class B, you have to wait for the downlink. And even the uplink is also not that fixed, because if sometime there is interference, uplink will be lost. Okay, so you can send only small packets every couple of minutes. It cannot be used for real-time application. Okay, and phone calls, it cannot be used. And controlling lights in your house, you can use Zigbee or Bluetooth or Wi-Fi. There you cannot use. Sending photos or watching videos, again you cannot, you can use Wi-Fi, not required. And geolocation and triangulation, yeah, LoRaWAN can do a certain bit of geolocation, geofencing and all, but GPS is more accurate. You can go for that, right? Fine. So LoRaWAN, as I said, LoRa is by Semtech. It's a proprietary radio technology, but LoRaWAN is an open source. We have two types of open source implementation. One is the Things network. Okay, so this Things network is a LoRaWAN network, which is an open source community driven network. Okay, open source community driven network in the sense, as I said, in order to build a LoRaWAN network, you need an end node, you need a gateway, and you need a server. Okay, so you can buy end node, but where to go for gateway and server? Either you can buy a gateway and connect it to the Things network server. Okay, the Things network server is the network server and application server deployed in the Things network server. Okay, so or else you can use the existing LoRaWAN gateway in your area. So I will show that in a minute. Okay, so why use Things network? Because it's free of charge, it's open source, it has active user base. Okay, you can easily connect your devices, you can add your applications and gateway, you can easily stream data using MQTT, and you can do a lot of integration. And you can see worldwide free network for makers and driven by community. So that is what the TTN provides. So let's see what TTN is. Okay, so I will just open my browser. One second. um, let's go to the browser. I think, hope you can see this. So here if you go and if you search for TTN, Okay, so the TTN is the things network. Okay, uh, okay, let's go TTN LoRa. I'll just zoom a little bit. If you go for things network, okay, so as I said, right, so end node, gateway,
Sir,
both are hardware, but
sorry
for
to
the
interrupt.
software. Hello.
Sir,
Yes,
excuse
sir.
me.
Yes,
Sir,
sir. Yes, sir.
in another 5 minutes, we have to end this technical session one for a
Yeah,
next.
yeah, yeah, sure, sir. That's why I'm this is just 5 minutes, sir. I'll just
Okay,
show that
got it.
and
Please go.
yeah. Okay. Yeah. So yeah, we have this things network which has the network server and the application server in the backend. Okay. So meanwhile, if you have any questions, you can drop it in the chat box. Okay. I'll try to answer it. And you can see here, it is the global map. Okay. So if you see this region, Europe region, you can see 7,600 gateways deployed over there, because LoRaWAN is a technology is being developed in the company called Netherlands. Okay, so the Netherlands, TTN by Netherlands and Amsterdam. Okay, so Europeans only actually created this protocol, but slowly it's moving into US. Previously, US there is no that much network in the US. Now there's been quite good number, and in India you can see this many devices. So let's see, get to India and see how many devices are there. Okay, so in India, in South India, let's come here. Okay, so this is the network. I'll try to zoom in a little bit. Okay, so here you can see Karnataka and Bangalore. Let's see about Tamil Nadu and how many devices we have in Tamil Nadu. So in Coimbatore we have 5 devices. Okay, so if you zoom in further, so we have one here. Okay, so this is actually the gateway sitting in my house. Okay, so it's a new LoRa gateway. Altitude is 450 meters. Okay, and it's a Raspberry Pi based. So it's a Raspberry Pi based. I have converted a Raspberry Pi gateway, Raspberry Pi device into a gateway, and the radio data concentrator I'm using is RAK2245. Okay, so it's the radio module attached to a Raspberry Pi gateway. And you can also see some thing here and something here and something in here. Okay, so all these things are LoRa gateways which is connected to the things network server. Okay, so and you can see there are about 16K gateways in 150 countries. So you have a gateway. If you are in the range of this particular gateway, the only thing you need is you need to have the node, and you can use the node to connect to the gateway, and you can transmit the data in and out. Okay, so we'll log in and we will create our own devices, and we will see all sort of things in the second session. Okay, so we will end this session by now, and if you have any questions, you can ask in the chat box, or else unmute it and you can ask me. Okay, okay, thank you, ma'am. Yeah, so we have a lot more things to cover. In the second session we will build an internal, so you can see the application, cattle tracking, smart irrigation, smart parking. Because see, if you go for cattle tracking, okay, so cattle tracking, cattle can roam anywhere, right? So in that case, if you need a long range, the only option is mobile network. So you cannot go for buying hundreds of sims, mobile sim card, or else you cannot go for eSIM for those many devices. And also battery is, the battery is draining. So if you go for LoRaWAN, it can cover up to few kilometers. So mostly cattle will not cross more than 5 kilometers within the region, so that you can easily build application on that. Okay, and also for irrigation, parking, and for all sort of applications, you can build things, right? So yeah, so it's a LoRaWAN stack. Okay, you have the gateways here, and you have the network server here. Okay, sorry, 1 second. Okay, you have the gateway, you have the gateway server, you have the network server, you have the application server, and you can monitor it, and you can add all the devices, and you have a lot of integrations. That is what TTN provides. And there is also another open source implementation called chip stack chirp stack. Okay, CHIRP STACK. So it's an open source, same this TTN, same thing, but it is run by a company called the Things Network, but it's completely open source. You can install on your system on your own, and you can do the stuffs. Okay, we will see the chip stack and TTN, both the stuffs we will see. Okay, fine. Any questions? We have 2 more minutes. Any questions? You can drop in the chat box.
Can I ask a question? Like, I have few
Yes, sir.
questions.
Yeah.
Yeah, like you explained that particular figure where there were multiple gateways involved and the number of nodes associated with different the nodes at the same time. So I
Yeah.
would like to know what is the rationale behind actually multiple nodes being associated with the gateways. Don't you think there would be battery degradation because of that redundant data being communicated through the gateways to the server?
Yeah, that's there, sir. But if you talk about gateway is connected to the server through a internet connection, and also
Yeah.
it has a mains power. But gateway is not battery operated, right? So gateway is always
But
listening.
what about the nodes? Because that redundant same thing
Node
has
will
to be.
just That's the I'm telling. Node will just transmit a LoRa packet. Okay, that's all. That's all the node does. It will transmit only one time. But
Okay.
whoever the gateway is able to listen to the node, they will receive the data, or else they will not receive the data. That's all. It will not send data to multiple gateways multiple times. It will
Okay.
just transmit
Uh,
something, and
okay.
the gateway receives
One
it.
more thing is that some of the gateways are associated with UDP, as you said that
Yeah,
there might be TCP or UDP in some cases.
yeah.
But don't you think there would be a security issue in that case? Because if in case UDP you don't get the confirmation back, and maybe
Yeah,
somebody
so
could.
here in the UDP, there is no security, there is no encryption, but LoRa itself uses its own two-way encryption system. It uses a key called network session key and app session key. I'll tell you that. Okay, so in the second session. Okay.
Okay, well, lastly, one more thing.
Yeah,
Since we are using Star Network, as you
yeah,
mentioned,
yeah.
don't you think there will be a bottleneck issue in that several nodes being accessing the same gateway?
Yeah,
So
definitely. There'll be a bottleneck, and sometimes there will be interference. But it's a star of star. Let's say you are having like a more gateway. So how the network is designed is, see. Let's 1 second. I will just get back to the uh, drawing board so that I
that
can
figure, yeah, that.
figure.
Sir, shall we wind up the technical session once or now?
Yes, sir. So 2 minutes, sir. I'll finish. 2 minutes.
Ah.
I'll just answer this question. Will close it. Okay. So let's say you have a gateway here. Okay. So you have a gateway here, and let's say this gateway is covering this region, and this gateway is covering this region. Okay. So there will be overlap between the coverage. Okay.
Yeah.
But let's say the nodes in this region will have only access to this gateway. So
Okay.
what we can do is, let's say this node is not mobile, this is fixed. In that case, we can configure the spreading factor, we can configure the power, we can configure the bandwidth, and we can configure the data rate. So all these things either we can configure, or else the network server itself can modify all these things. Okay, so that, see, it knows the distance. So what it does is, initially it sets the data rate for 0 means long range. So this
Yeah.
node can transmit up to this area, so in all
Okay.
the direction this area, so that whatever the gateway is within this region can receive all the data. But data rate 0 is not needed, because there is a gateway which is close to the node itself, so it
Yeah.
will keep on reducing it. Data rate 1, 2, 3, 4. So 4, if it goes 4, then the range will be shortened, but the bandwidth will be increased.
Okay.
Okay, so in that case, this node will be limited only to this gateway. But
Okay.
even though this gateway also listens, it transmits only once. But whichever the gateway is within the range of this node, every gateway will receive the data. But
Okay.
if it is connected to a single network server, this two redundant data will be deduplicated and made into one data.
So the direction is omnidirectional, so it doesn't matter actually. You're not going to multiple send them. You just
Yeah.
send it
It's not
once.
like that. It's just a broad. It's in all
Broadcast.
direction that
Yeah.
broadcast. That's all.
Okay. Thank you.
Okay, sir. Yeah. So we are closing now and getting back by 11:30, right?
Dear participants, you are expected to rejoin to the technical session 2 sharply by 11:25 a.m. Okay, thank you.
Okay, sir.